We've gone back to our two switch network for the next couple of videos, switches 1 and 2. Switch 1 is the root as it has been before, switch 2 therefore the non-root. We'll still verify that in just a moment, and they're trunking over their fast 11 and 12 ports. So let's go ahead and verify all of that before we jump in. And we've also got some VLANs added. We'll get to that. Let's do a show interface trunk, and we see our two trunks 11 and 12. And what else? Show VLAN brief. I want to show you the VLANs I created during the break, 10, 20, 30, and 40. Both switches 1 and 2 know about that. I put them in a VTP domain CCNA so they could share that information. And let's see what else we want to do. Let's run a show spanning VLAN 1. And we're going to see here exactly what we expect to see, what we saw in some earlier videos, is that the trunk over fast 11 on each switch, that's going to handle all the traffic right now. Because on switch 2, the non-root, port 11 is in forwarding mode, port 12 is in blocking mode. We know why. We've seen that in action. And, there may be nothing wrong with that, but maybe we want to do a little load balancing. Because right now, any traffic that goes between switches 1 and 2 over that trunk, it's all going over the same trunk, the trunk over fast Ethernet 11. The one with fast Ethernet 12, it's a perfectly operational trunk, nothing wrong with it, but it's just sitting there. So maybe we want to change that up a little bit. Before we do that though, I want to show you how to change the cost, the STP port cost, period, for all VLANs, because there's one little difference in these two commands we're going to concentrate on in this video, and the difference is huge. You really want to watch this on exam day. Now, if I just want to change the port cost on fast Ethernet 12 and make that the root for every single VLAN, I can do that by changing its cost with this spanning tree cost command. Now let's just go ahead and go to fast 12. And what I'm going to use here is the cost command, change in interfaces spanning tree port path cost. Makes perfect sense. And the range is 1 to 2 zillion. And I don't know if you'll ever use that 2 zillion or whatever that actually is. It's real big, and we don't need to go that high. But what we want to do is make it less than 19. So we'll go with about halfway there, since we can't do 9.5. Spanning cost 9. And no options. Hard to believe, but there we are. So let's go ahead and run show spanning VLAN 1 right now. And a couple of things have already taken effect. First off, you can see the cost has already changed to 9, and port 12 is now the root on the switch. Port 11's already gone into blocking mode, but notice that port 12 didn't go from blocking to forwarding immediately. We know why. We've got those transition states, and we've got to have those in order to prevent any kind of switching loop. So we're in listening mode at that point. We're already in forwarding right there. So while I was talking, it went through listening mode and then through learning mode and then to forward. Now, nothing wrong with this command if this is what you want to do. So all this does at this point though is now all the traffic that goes between switches 1 and 2, it's going to go over fast Ethernet 12. So again, when you use the spanning cost command, that is an all or nothing deal. Because right now, if I run show spanning VLAN 10, we're going to get the same thing. If I run 20, we get the same result. Fast Ethernet 12 is going to be in forwarding for all of them, and port 11 will be in blocking mode. Let's do 30, same thing, and we'll do 40, and we're not surprised to see the same thing. Again, nothing wrong if that's the effect you want, but what we might want to do is some of what we call per VLAN load balancing. Because again, right now we got all the traffic between 1 and 2 going over one trunk, and maybe we don't want that. We like load balancing. We like spreading the workload a little bit. Tends to be a little more efficient. One way of approaching this is with per VLAN load balancing, and that's exactly what we're going to configure here. Because what we want, what the lab requirements are, is that VLANs 10 and 20, traffic for those VLANs is going to go over fast Ethernet 11's trunk, and then traffic for VLANs 30 and 40 is going to go over the other trunk. So it's not absolutely totally precise load balancing. You're not saying, okay, I want 47.5% of the traffic to go over this trunk and 52.5% to go over the other trunk. But it's better than one trunk handling all the traffic. And if you do a little traffic analyzation with Sniffer or whatever you've got handy, you could pick which VLANs you wanted to go on each trunk. And that's what we're going to do here. Again, we're going to keep the traffic for VLANs 10 and 20 going over fast Ethernet 11's trunk. 30 and 40, we're going to move that down to 12. So let's go ahead and dive in. What I want to do first is get rid of that previous command. So I'll just put a no in front of it. And we're going to use almost that same command, but not quite. Definitely something you want to watch out for on exam day. And we're going to change the cost for VLANs 30 and 40 only to 9 on that particular port. So let's see how in the world we're going to make that happen. Now we saw when I used spanning cost, we never had an option here, right? I mean, we had spanning cost 9 and create. There's nothing there about a VLAN. So what you have to do instead is use the spanning VLAN command, not the spanning cost command. And now you can put in a range, and you can use hyphens here for a larger range. You can use commas to separate individual VLANs. That's what we will do here, because what I want to do is change the cost only for VLANs 30 and 40. And now you see the cost option after this. So that little word VLAN there and a couple of numbers makes all the difference. And again, 1 to 2 zillion is our option. And we're going to go with 9, and that's it. But notice change in interfaces per VLAN spanning tree path cost. So a big difference there. And let's go ahead and enter that. And right now, if I run show spanning VLAN 10, there are no changes. Port 11 is still forwarding. Port 12 is still blocking. If I go to 20, nothing has changed. The costs don't change. Notice that? It's really great. So we got 30. And the cost did change. So now port 11 is in blocking mode and port 12 is going to be in forwarding mode very shortly. It's in learning mode right now. And there you go. So VLAN 30, now all the traffic for VLAN 30 is actually going over the trunk on fast Ethernet 12 on each switch. And now if we put in 40, same thing. So that's per VLAN load balancing, and it's just that simple. Again, it is not precise to the decimal or to the bit load balancing, but now any traffic going over VLANs 30, going from VLANs 30 and 40, that's going to go over the trunk on fast 12. And now all other VLANs, even ones we add in the future now, beyond the 1, 10, and 20 we have now, that traffic is all going to go over fast Ethernet 11. So some great stuff there as far as per VLAN load balancing goes. We're going to look at another method called an ether channel, where we're not just wasting that backup trunk. It's just sitting there. We definitely want to use it, but this can be an efficient way of getting some load balancing into your switching network, and we'll also see how to do some of this in the routing network as well, because we like spreading the workload. Again, it's always much more efficient that way. So coming up next, though, we need to talk about how to change a root switch, maybe be a little more deterministic about which switch is going to end up being our root and why, and that is all coming up next.